Imagine a place where the very concept of time is blurred under the pressure of colossal gravity and unbearable solar wind. A world where the sun appears 3 times larger than we are used to seeing from the doorstep of our own home, and its rays do not grant life, but turn everything living into ashes in a matter of moments. This is not a fiction of science fiction screenwriters, nor a description of hell from ancient legends. This is the reality of our closest neighbor to the sun, the planet Mercury. Most of us are used to considering Mars as the main goal for future colonization and Venus as the hottest planet due to its greenhouse effect. However, Mercury remains one of the most mysterious and dangerous objects in the solar system. Why does this iron sphere, which is only slightly larger than our moon, possess a power capable of incinerating a person in a few seconds? Today, we set out on a journey to a place where the laws of physics test the limits of the possible. We will understand why, despite the hellish heat on the day side, ice that never melts may be hidden in the craters of Mercury. We will look into the depths of this planet, which consists almost entirely of red-hot iron, and understand how the magnetic field of this small planet tries, but cannot protect it from the devastating fury of our star. The National Aeronautics and Space Administration of the United States of America and the European Space Agency have spent decades and billions of dollars to get closer to this scorched rock. The data received from the Mariner 10 and Messenger missions shocked scientists. We will find out why even the most modern spacesuits of the future will not be able to save you from a thermal shock if you take even one step on the sunny side of this planet. Prepare for a detailed dive into the extreme physics of space. The absence of an atmosphere, an anomalous orbital speed, and constant bombardment by solar particles all make Mercury an ideal platform for studying how worlds are born and die. This is a story about a rogue planet that is too close to the fire, and about what will happen to a person who dares to violate its solitude. Welcome to the most detailed analysis of the deadly secrets of Mercury. The history of our acquaintance with Mercury is a chronicle of human perseverance fighting against the insurmountable radiance of our mother star. For thousands of years, this planet remained an elusive ghost in the night sky, a tiny speck appearing only for brief moments before dawn or immediately after sunset. Ancient observers, who did not have modern digital detectors or space telescopes, looked at this moving light with a mixture of wonder and awe. The first documented mentions of Mercury go back deep into the ages, to the civilization of the Sumerians in the second millennium before the Common Era. They called it Ubu Idim Gud Ud, which translates as the jumping planet. Later, Babylonian priest astronomers, who were extremely accurate in their calculations, gave it the name Nabu after the god of wisdom and writing. Why exactly wisdom? Perhaps because tracking such a fast and complex object required considerable intellectual effort. The ancient Greeks initially believed they were seeing two different objects. They called the morning star Apollo after the god of light, and the evening star Hermes, the cunning and fast messenger of the gods. It was only in the 4th century before the Common Era that thinkers such as Pythagoras began to realize that it was the same celestial body. Eventually, the name Hermes prevailed, and in the Roman tradition, it transformed into Mercury. This name was perfect. The planet revolves around the sun in only 88 Earth days, moving in orbit at an incredible speed of almost 48 kilometers per second. However, a real scientific analysis began only with the invention of the telescope. In the year 1610, the great Galileo Galilei pointed his primitive instrument at Mercury. He was disappointed. Due to its proximity to the sun and the imperfection of the lenses, the planet looked like a blurred spot. Only in the year 1639 did the Italian astronomer Giovanni Zuppi discover that Mercury has faces similar to those of the moon. This became fundamental proof that the planet revolves around the sun and not the Earth, which undermined the foundations of the geocentric picture of the world of that time. However, the greatest mystery of Mercury awaited scientists in the 19th century. Astronomers noticed strange behavior of its orbit. The point of closest approach to the sun, which we call the perihelion, gradually shifted. This phenomenon was called precession. Calculations based on the laws of Isaac Newton could not fully explain this shift. The deviation was tiny, only 43 arcseconds per century, but for precise science, it was a catastrophe. In the year 1859, the French mathematician Urbain Le Verrier, who had previously theoretically predicted the existence of Neptune, put forward a bold hypothesis. He suggested that inside the orbit of Mercury there exists another planet whose gravity affects it. He even gave it a name, Vulcan. For decades, astronomers around the world tried to find this ghostly world during solar eclipses. But all attempts were in vain. The solution came not through a new planet, but through a complete revision of our understanding of the universe. In November of the year 1915, Albert Einstein presented the general theory of relativity. He proved that the mass of the sun is so enormous that it curves the very fabric of space and time. Since Mercury is in close proximity to this gravitational well, its orbit curves exactly as the observations predicted. It was a triumph of the human mind. We realized that Mercury is not just a planet, but a unique laboratory for testing the laws of physics in extreme conditions. Today, looking at the reports of the National Aeronautics and Space Administration, we understand that every historical step was a preparation for that shocking discovery we made with the help of space probes. Mercury is a place where time, space, and matter behave completely differently from what we are used to on our cozy Earth. But before we dive into the data of modern missions, we must understand the physical nature of this iron world. To understand why Mercury is so deadly, we must look under its sun-scorched surface. If Earth is a living planet with a thin crust and an extensive ecosystem, then Mercury is a giant iron core, barely covered by a thin layer of rocky rocks. Astrophysicists often call it the iron planet, or even the cosmic cannonball. And this is not just a metaphor. According to data obtained by the National Aeronautics and Space Administration mission MESSENGER, the core of Mercury occupies about 85% of its radius. For comparison, the core of our Earth is only about half of its radius. This creates an incredible gravitational anomaly. Despite the fact that in size Mercury is only slightly larger than the Moon, it is almost twice as heavy as it. Why did this happen? In the scientific community, particularly on the pages of the journal Nature, disputes have been going on for decades. The main theory suggests that at the dawn of the formation of the solar system, about 4.5 billion years ago, Mercury was much larger. Perhaps in size, it was close to the young Earth. However, a colossal collision with another planetary embryo, a so-called planetesimal, literally stripped off its light rocky crust and most of its mantle, leaving only a heavy metal heart. This collision was so powerful that the fragments of the former Mercury scattered throughout the inner part of the system, and what remained became that red-hot core we observe today. When you look at images of the surface of Mercury, you see a world mangled not only by craters from asteroids, but also by giant tectonic faults. These formations, which scientists call low-bat scarps or escarpments, stretch for hundreds and thousands of kilometers. Official reports from the European Space Agency indicate that these structures are evidence of a unique phenomenon. Mercury is literally shrinking. Since its huge iron core is gradually cooling, it decreases in volume. Imagine a grape turning into a raisin. The skin becomes too large for the shrinking pulp and begins to crack and crawl over each other. Calculations show that over the last 4 billion years, Mercury has decreased in diameter by approximately 14 kilometers. This causes Mercury quakes, powerful seismic shocks that could destroy any structure if humanity dared to build something there. One of the biggest surprises for scientists was the discovery of the magnetic field of Mercury. According to all the laws of physics, such a small planet should have cooled inside long ago, and its magnetic dynamo should have stopped, as happened with Mars. However, data from onboard MESSENGER confirmed. Mercury has an active magnetic field, although it is only 1% of that of the Earth. This field creates a magnetosphere around the planet, but it is too weak and located too close to the Sun. The solar wind, a stream of charged particles flying from our star at a speed of millions of kilometers per hour, literally presses the magnetic field of Mercury into its surface. This creates zones of extreme radiation. If you find yourself on the surface, you will be subjected not only to thermal radiation, but also to bombardment by heavy ions and X-rays, from which the magnetic shield of the planet is simply not able to protect you. The most mysterious objects on the surface are the so-called hollows. These are bright, shallow depressions with irregular shapes that are not like any other geological object in the solar system. Leading planetologists, such as Dr. Sean Solomon, the principal investigator of the Messenger mission, suggest that these voids are formed due to sublimation, a process in which solid minerals under the influence of merciless solar radiation turn directly into gas, bypassing the liquid phase. The planet is literally evaporating into space. The central point of the geology of Mercury is the Caloris Basin, one of the largest impact craters in the solar system. Its diameter is about 1,550 kilometers. The impact of the asteroid that created this basin was so powerful that seismic waves passed through the entire planet and focused on the opposite side, creating a chaotic landscape known as weird terrain. This clearly demonstrates how fragile this world is under the strikes of outer space. We see that Mercury is not just a dead rock. It is a dynamic, aggressive system where the internal heat of the iron core fights with the external fire of the sun. Every law of thermodynamics is proven to the point of absurdity here. But how exactly do these conditions affect the possibility of the existence of something other than red-hot stones? Why, in this hell, did scientists find what they least expected? Water. Mercury is a large scientific anomaly that questions our models of the formation of the solar system. When we look at the results of the Messenger mission, we see facts, but the interpretation of these facts gives birth to dozens of scientific discussions. In this block, we will analyze the boldest theories and look into the future, where the most complex research complex in human history is already on approach to the first planet. Why does Mercury consist almost entirely of iron? Official science offers three main scenarios, each of which has its supporters in the journals Science and Nature. The first and most popular theory is the theory of a giant collision. It claims that about 4.5 billion years ago, Mercury was 2.5 times more massive than it is now. It had a thick silicate mantle similar to Earth's. However, a catastrophic collision with an object the size of a large asteroid or even a small planet blew the light rocks into open space. Only the heavy core remained, which quickly cooled and shrank. The second hypothesis is the evaporation theory. Some scientists, relying on models of the early sun, suggest that our star at the stage of its formation was much hotter and more active. The temperature in the orbit of Mercury could reach 10,000 degrees Celsius. Under such conditions, the rocky rocks around the iron core simply evaporated, turning into gas, which was subsequently blown away by the solar wind. The third, more exotic version is aerodynamic drag. According to this model, in the protoplanetary disk from which the planets were born, gas exerted strong resistance to the movement of small particles. Heavy iron grains easily overcame this resistance and accumulated closer to the sun, while lighter rocks were pushed further away. Thus, Mercury was baked already rich in metal. One of the most shocking discoveries, confirmed by the Arecibo radio telescope and the Messenger probe, was the presence of water ice at the poles of Mercury. How is this possible on a planet where hellish heat reigns? The answer is hidden in the zones of eternal shadow. Since the axis of rotation of Mercury is almost perpendicular to the plane of its orbit, solar rays never reach the bottom of deep craters at the poles. Eternal night reigns there, and the temperature is about -200 degrees Celsius. Scientists suggest that this water was brought by comets billions of years ago. Ice does not just lie there. It is covered with a layer of mysterious dark organic matter, which scientists call Mercury anthracite. This discovery forces us to reconsider the boundaries of exactly where in space water, the foundation of life, can be stored. Right now, while you are watching this video, through cosmic space speeds the Bepi-Colombo mission, a joint project of the European Space Agency and the Japan Aerospace Exploration Agency. This is not just one apparatus, but a whole bundle of two orbital probes, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter, which the Japanese affectionately call MAIO. Why is this mission so important? First, Bepi-Colombo is equipped with instruments capable of seeing through the surface. We will finally find out if the core of Mercury is completely liquid or if it has a solid heart, like Earth. Second, the Japanese apparatus MAIO will focus on studying the interaction of the planet with the solar wind. We will see how the magnetic field of Mercury fights for its existence, creating giant magnetic tornadoes. Third, scientists plan to map the chemical composition of the surface with an accuracy of up to a meter. This will allow confirming or refuting the theory that Mercury was once covered with an ocean of liquid graphite. This journey lasts 7 years. To enter the orbit of Mercury, the apparatus had to perform 9 gravitational maneuvers near Earth, Venus, and Mercury itself. This is due to the incredible complexity of braking. The Sun attracts objects so strongly that it is easy to fall onto Mercury, but staying in its orbit is a real engineering feat. What do we still not know? Despite all efforts, Mercury remains a white spot. We are still not sure if there are active volcanoes on it. We do not know the exact nature of the dark substances at its poles. And most importantly, we do not know how such a small planet was able to preserve its magnetic field for billions of years. Every new answer only generates a dozen new questions, making this iron world even more attractive for future generations of scientists. Is it possible that Mercury will become the key to understanding how humans will survive in other star systems? Or will it forever remain a forbidden zone where only the pure energy of the Sun reigns? Welcome to the true epicenter of thermal chaos. If you want to understand why Mercury will burn you in a matter of seconds, we need to analyze the physics of how solar energy interacts with a celestial body that has no protective armor. On Earth, we are protected by a thick blanket of atmosphere and a powerful magnetic field, which dissipate heat and filter out deadly radiation. On Mercury, these barriers practically do not exist. You are left alone with an angry star. The first thing to realize is the intensity of solar radiation. Mercury is at a distance of approximately 58 million kilometers from the Sun. This may seem like a large number, but on a cosmic scale, it is literally point blank. Because the planet moves in an extremely elongated elliptical orbit, at its perihelion, the point of closest approach to the Sun, it receives 10 times more solar energy than Earth. Here the law of inverse squares comes into play. If you approach a light source twice as close, the intensity of the radiation increases 4 times. The solar disk in the sky of Mercury looks 3 times larger than we are used to. This is not just bright light. It is a stream of photons of such density that it is capable of exerting physical pressure on the surface of the planet. Every square meter of Mercury soil during the day absorbs about 9 kilowatts of energy. This is the same as pointing 6 powerful industrial heaters at yourself at the same time, while being at arm's length from them. The temperature on the day side of Mercury rises to 430 degrees Celsius, so that you can imagine this scale. Lead melts at a temperature of 327 degrees, tin at 232. That is, on the surface of Mercury, molten puddles of metals could be a common occurrence if they were found there in their pure form. But the most terrible thing is not just in the figure, but in how this heat is transferred. On Mercury, there is no air that could transfer heat through convection. All the heat you receive is direct radiant radiation. If you stand on the sunny side, your front part of the body will literally evaporate, while the back part, which is in the shadow, will remain icy. This creates incredible tension in any material, including the metals of spacecraft and biological tissues. Why does Mercury not retain this heat as Venus does? Venus is the hottest planet in the solar system because its ultra-dense atmosphere creates a greenhouse effect. On Mercury, however, the situation is the opposite. It has no atmosphere in the sense we are used to. What scientists at the National Aeronautics and Space Administration call an exosphere is an extremely thin gas consisting of atoms of hydrogen, helium, sodium, and potassium. These atoms do not fly freely like the air around us. They move along ballistic trajectories. The solar wind knocks them out of the surface of the rocks. They rise up and fall back to the surface or fly out into open space. Due to the absence of atmospheric pressure, any liquid on Mercury instantly boils and turns into gas. This means that if you took off your spacesuit, your blood and all fluids in the body would turn into steam even before you had time to feel the burn from the sun. When the sun sets behind the horizon of Mercury, another extreme begins. Since there is no atmosphere that could retain daytime heat, the planet instantly gives it away to the black void of space. The temperature drops to minus 180 degrees Celsius. This is the lowest temperature among all the planets of the terrestrial group. Such a drop, from plus 430 to minus 180, is over 600 degrees Celsius. No other planet knows such an extreme contrast. This creates conditions under which stones on the surface constantly expand and contract, which leads to the physical destruction of mountain rocks. Mercury literally crumbles into dust under the action of temperature fluctuations. Another amazing phenomenon discovered by the MESSENGER mission is the sodium tail of Mercury. Under the action of radiation pressure and the solar wind, sodium atoms from the exosphere are pushed in the direction opposite to the Sun. This creates a huge tail millions of kilometers long, making Mercury look like a giant comet. We live next to a planet that is constantly losing its own mass, scattering it in interplanetary space through the fury of our star. All this leads us to the main question. If the physics of the planet is so aggressive, is there at least a theoretical chance for a person to survive on this red-hot rock for at least a few minutes? And what exactly will happen to our body in this iron hell? Now we come to the most eerie part of our research. We have considered the iron core, thermal anomalies, and magnetic storms. But what will happen if you, a person of flesh and blood, find yourself on the surface of Mercury without the protection of a spaceship? This is not just a theoretical question. This is an analysis of how the fundamental laws of physics and biology enter into a deadly conflict under the conditions of the most aggressive environment of the inner solar system. Suppose you took a step on the day side of Mercury. Your first problem is not at all the heat. It is the complete absence of atmospheric pressure. On Earth, air presses on your body with a force of approximately 10 tons per square meter, which keeps internal fluids in a liquid state. On Mercury, the pressure is practically equal to zero. In a fraction of a second after leaving the airlock, you will feel an effect called ebulism. Due to the absence of pressure, the boiling point of liquids in your body will fall below your body temperature. The moisture on your tongue, in your eyes, and mucous membranes will begin to boil instantly. This will not be boiling from temperature, it will be boiling from low pressure. Your tissues will begin to swell as water vapor expands inside the muscles and under the skin. You will not explode like in cheap Hollywood movies, but your body will increase in volume almost twice in a few seconds. Now the sun enters the game. I remind you, the temperature on the surface reaches 430 degrees Celsius. This is much higher than in an ordinary oven while baking bread. Since there is no air on Mercury, heat is transferred exclusively through direct radiant radiation and thermal conductivity of the soil. If you were standing on the surface, the soles of your shoes, if you had them, would melt instantly. But even without contact with the ground, the infrared radiation of the sun will begin to literally cook your skin. Denaturation of proteins occurs. The long molecular chains of which you consist will begin to break down and rearrange under the action of colossal energy. Your skin in a matter of moments will turn into a continuous fourth-degree burn, and subcutaneous fat will begin to melt. Even if you close your eyes, the intensity of light on Mercury is 11 times higher than on Earth. The stream of photons is so powerful that it will pass through your eyelids, burning out the retina of the eye in a fraction of a second. You will go blind instantly. Your blood, which has already begun to be saturated with vapor bubbles due to the absence of pressure, now receives a huge portion of thermal energy. Since the heart will still try to pump this mixture, you will feel unbearable pain in the chest. The lungs, instead of supplying oxygen, will begin to work in the opposite direction. Due to the difference in pressures, oxygen will be washed out of your blood into open space with every semi-conscious breath. You will lose consciousness from hypoxia, which is oxygen starvation of the brain, in about 10 to 15 seconds, which will probably be the only merciful moment in this situation. While heat and vacuum destroy your shell, invisible killers, X-ray and hard ultraviolet radiation penetrate deep into your cells. On Mercury, there is no ozone layer. Every high-energy photon crashes into your DNA, tearing it into pieces. Even if you were saved in 5 seconds, your cells would already have lost the ability to regenerate. You would die from acute radiation sickness in a few days, but on the surface of Mercury, you do not have these days. You have only seconds. You may ask, what about modern spacesuits of the National Aeronautics and Space Administration? Modern spacesuits used by astronauts on the International Space Station or those being developed for the Artemis program are designed for extreme conditions, but not for the conditions of Mercury. The main problem is heat removal. In a vacuum, you cannot simply cool off with a breeze. The only way to get rid of heat is radiation or evaporation of water in special cooling systems. On Mercury, the external energy flow is so powerful that no portable cooling system can cope with it. The radiators of the spacesuit themselves will begin to absorb heat from the sun instead of radiating it. After a few minutes of being under direct rays, the life support system will simply fail, and you will boil inside your own protective suit. Thus, Mercury is a place where nature has put up a sign saying entrance strictly forbidden. It is a world that is not just inhospitable, it is actively hostile to the very structure of organic matter. Any attempt at a human landing on the day side of this planet without colossal underground structures or mirror shields the size of a city is pure suicide. But does this mean we must give up on Mercury? Or perhaps in this hellish fire, something is tempered that will help us understand our future? We have come a long way from the first observations of the ancient Sumerians to the ultra-modern calculations of the Bepi-Colombo mission. We have looked into the red-hot iron core and felt the fury of the solar wind stripping the planet of its very flesh. Now, when we understand why Mercury is capable of incinerating a person in a few seconds, the main question remains: why do we need to know this? What is the point in studying a dead, hostile world where we will likely never be able to land? The answer is much closer to us than it seems. Mercury is not just a planet, it is a warning. Astrophysicists, relying on models of star evolution, know that our sun will not be eternal in its current state. In 5 to 6 billion years, it will exhaust the hydrogen reserves in its core and begin to turn into a red giant. During this process, the sun will begin to expand, swallowing Mercury, then Venus, and, quite possibly, Earth. Today's Mercury is what awaits our planet in the distant future. By studying how the first planet interacts with extreme radiation, how its magnetic field tries to resist plasma, and how its minerals evaporate, we are effectively reading the last pages of the biography of our own planet. Mercury is a laboratory where we see the final of any world that has found itself too close to its star. But the gaze of Mercury is directed not only into our future, but also far beyond the borders of the solar system. Most of the planets we find near other stars are so-called exoplanets orbiting red dwarfs. These planets are often very close to their luminaries, being in a state of tidal locking, where one side is always turned to the fire and the other to eternal darkness. Mercury is the only object right next to us that allows us to model conditions on billions of such exoplanets throughout the Milky Way. Understanding the chemistry of Mercurian hollows and the behavior of its exosphere, we learn to recognize signs of habitability or its complete impossibility in worlds that humanity will not reach for thousands of years. Without knowledge of Mercury, our picture of the universe would be incomplete, like a blurred image of Galileo. Looking at these hellish craters and iron deserts, we begin to feel more acutely the uniqueness of our own home. Earth is in the so-called Goldilocks zone, where the distance to the sun allows water to be liquid and the atmosphere to breathe. Mercury reminds us how thin the line is between a cozy garden and the ashtray of space. This gives birth to a philosophical realization. We are the only species known to us that was able not just to survive in this chaos, but also to construct apparatuses capable of challenging the fury of Mercury. Every figure in the reports of the National Aeronautics and Space Administration, every photograph from the European Space Agency, is a monument to human curiosity. We are small, we are fragile, we will burn in seconds on the surface of this planet, but our mind is already there. It is already measuring magnetic fields and mapping ice in the eternal shadow. Mercury will never become a second Earth for us. It will not grant us resources that are easy to extract, and will not become a place for colonies under domes in the next century. It is a lesson planet, a lesson in physics, a lesson in endurance, and a lesson in modesty. It will burn you in a matter of seconds, not because it is evil, but because it is the embodiment of pure, unrestrained energy of the universe, where a very narrow corridor is allotted for life. And our goal is to protect this corridor while simultaneously continuing to look beyond its borders. We have told you the story of the iron heart of our system, about a world where a day is longer than a year, where ice neighbors with molten metal, and where the silence of space is torn by the roar of the solar wind. What do you think about Mercury after everything you have heard? Are these knowledge worth billions of dollars and decades of waiting for probe flights? Or perhaps humanity should focus on more hospitable worlds? Click like and subscribe to the channel. Share your thoughts in the comments below. Your activity helps us create even more detailed and deep analyses of the mysteries of our space. Do not forget to subscribe and give a like if this journey to the fiery boundary was interesting for you. Thank you for being with us. Until we meet in the next investigations, where we will continue to decipher the codes of the universe.